Now we'll be looking at what happened to electrons when they get to the various electrodes, like to be precise, the cathode. The cathode. Let's look at the cathode. The cathode is an electrical conductor where electron gets the ions in the electrolyte, especially the positive ion, which are opposite charge to the cathode. Positive ion, the cathode is what negatively charged, so they attract. So the cations are positive charged ions that migrate or are attracted to the cathode. So there's an attraction between the positive ions known as what? Cations. Cations always go to the what? The cathode. Is a C for C. Cations migrate to this is a cation, positive what? Ions. For example, if you have this like magnesium ion, you have calcium ion, sodium ion, and hydrogen ion. All these ones are in aqueous state. In aqueous state. All of these are cations. They all go to the what? Cathode. Right? All of these are cations. Cations. Cations all migrate to the cathode, where they are discharged with preference to the one that is lower in the electrochemical series. So those are cations all migrate here, and one of them will, not all of them, one of them will collect or remove electron to be discharged at the cathode. So the cations take or remove electrons from the cathode to form atoms or molecules. To form atoms or molecules. For example, if you have this, if you have sodium, probably I have sodium chloride. Yes, I add water, H2O. I have NaCl now aqueous. And these are the ions. I have sodium, chloride ions, and likewise water, H2O. So these are the ions, all in aqueous state. Sodium ion, chloride ion, hydroxide ion, then hydrogen ions. Now, these ions here, they are the ones that go, they're the positive ion, they go to where? To the cathode. They go to the cathode. Let's assume I'll discharge what? Hydrogen ion. Hydrogen what? Ion. And how does hydrogen ion, or how will hydrogen ion collect electrons from the cathode? So the hydrogen ion here, that is from the water. You can see, it can also be from an acid. The hydrogen ion plus electron, you have hydrogen atom, you have hydrogen ion again. I guess that you can see this is the cathode half-cell equation. Atom plus atom will now come together as molecule. That's the bubble. And this is aqueous ions. So the hydrogen ion is now discharged. Discharge means the charge is now become a what? A molecule. So hydrogen ion plus means to gain or accept or remove electron from where? This electron you're seeing here is from the cathode. From the cathode. Right? Plus means what? Electron accepted by this what? Cation. And it is now changed into a molecule. It is no longer charge. It's called discharge. It is reduction process. When this is called the cathode half cell equation for hydrogen. For hydrogen, because hydrogen ion is now reduced to hydrogen what? Molecule, because it's electron accepted by cations is called reduction or decrease in oxidation number. Right? This is +1 and this is what? 0. You can see that the serial number has decreased from +1 to 0, or hydrogen ion has accepted electron and it is now what reduced to hydrogen gas or molecule. So I'm trying to explain one thing, that what happened to cations when they get to the cathode. They collect or gain the electron, and this electron reduces the respective, depends on the cathode to be discharged, to their atoms or molecule. Very important. So these electrons are taken. So this is what you need. You don't need to go through this. This is what you try to achieve. This one. This is the discharge, or this is the acceptance of hydrogen ion at the cathode to form hydrogen gas or molecule. You don't need this and this just to build up this. So this hydrogen ion, if you add them up, you get 2 of this. 2 electrons, you add them 2. Atom give you molecule, right? So this is the acceptance. If you expand them properly, you see the hydrogen will come here, the electrons, right? The electrons will move from the cathode, and this becomes, see them? Atoms will now combine to give you this. That's a gas, right? That is the gas you get. Hydrogen ion has accepted 2 electrons, right? It's 2 electrons hydrogen needs to get from the cathode to be discharged as hydrogen gas, of which what you see in the distance of you see bubbles. If you have this, that means you'll be seeing bubbles around here, right? The only bubble or gas you find your electrolysis around the cathode must be hydrogen gas. Hydrogen gas is the only bubble you find around the cathode, because it's the only cation that comes here. No other cation does. The IGCSO level, hydrogen gas, right? They say this is the cathode and you see a gas bubbling. What is that gas? That gas must be hydrogen, which can be tested with what? A glowing spirit produces a pop sound, right? It's a colorless, odorless gas. It's very light. That's hydrogen gas, and bubbles around the negative what? Electrode. The only gas you find there is no longer any other gas besides what? Hydrogen gas. It's very, very important. This is one of it. I've just explained how hydrogen collects electron, get electron from the cathode, and at the end of the day discharge as hydrogen gas, right? Gas or molecule. We can have others like sodium. If molten sodium chloride is used, you see that only sodium ion will be discharged, right? It's just one of the ions to be discharged. So if here is plus, right, your charge determines how many electrons you have to get. This is +1, you take 1. If here is 2, this will take 2 electrons. This will take 2. Aluminium will take 3. So this is just 1, and you have this as Na. This an ion, the sodium ion, the sodium atom. It is now electrically neutral. Neutral. So this is discharge. This is what happened to sodium ion when it gets to the cathode. Likewise, you have magnesium. Magnesium lost 2 electrons before, right? During the process of ionization. Magnesium will gain it 2 electrons from where? From the cathode, and it will be discharged as magnesium atom. Likewise, aluminium, right? The charge is 3. They're positively charged. This will also gain 3. That's Al. So all these ones are atoms, right? These are the cations. Or the positively charged ions. So this is what happened to them. This is what happened to them when they get to the cathode. And this is what happened to the electrons that are being pushed by the battery. These electrons are used to reduce the respective cations. So they are various atoms, right? Not molecule. Molecule is purely for gases like hydrogen. Like hydrogen. I hope this is understood, right? So this is what happened to cations when they get to the cathode, and the electrons that flows from the battery, how they are removed, right? How they are removed, and these electrons are used in what? Discharge of what? Cations at the electrodes, at the especially the cathode, right? Don't forget. It's very important you understand this, right? It looks very graphic, but I hope this is understood, right? I hope this is what understood, right? This is what happened to the electrons that is being pushed by the battery and flows into the cathode and is being removed by cations, and these cations are invariably discharged as atoms or molecules. They become electrically what? Neutral, right? I hope this is understood.